let's try to solve this very nice geometry problem. We have a rectangle ABCD, right? And then we know the width is 12, the length is 17, and then we know this side of the triangle is 5, and um, and then this side of the triangle is of this big triangle is 7, right? This angle is 1, and this angle is 2. And we need to find out what's actually the summation of these two angles, angle 1 and angle 2, right? So how do we solve this problem, right? For now, the angle 1 and angle 2 are separated apart. They are actually very far away, right, inside of this rectangle. So if we can try to actually move either angle 2 over closer to the angle 1, or we can move angle 1 closer to angle 2, then it's gonna be easier for us to solve this problem, right? But now let's try to find out what's gonna be some of the edges of some of the triangles, right? So this is 12, right? And then this is 7. So FC is gonna be 5, right? So 12 subtract 7, that's 5. This side is 17, and this side is 5. So 17 subtract 5, it's gonna be 12, right? So this edge is 12. And then what? Let's connect E and F, right? Let's connect E and F. Connect E and F, right? With a straight line. So this is gonna be 5. This is gonna be 12. What's gonna be this length, right? This is a right angle triangle, right? So it's gonna be square root. It's gonna be 5 square, 25, plus 12 square, 144. It's gonna be 169, right? Square root of it. The square root of it is gonna be 13, right? So this edge of this triangle is gonna be 13, right? But let's look at this triangle and then this triangle, right? These two triangles are actually identical to each other because this edge is the same, 12, 12, right? This edge is the same, 5, 5, and this angle is the same, 90 degrees, right? So if this is 13, then this is 13 too, right? So this edge is 13. But don't forget, we're trying to actually move the angle 1 closer to angle 2, right? So because these two triangles are identical to each other, so this angle should be equal to this angle, right? So that's also angle 1, right? So now we have shifted this angle over here, right? So if we want to find out what's going to be the summation of angle 1 and angle 2, so all we have to do is to find this angle, right? If we know this angle, then 180 degrees subtract this angle, we get the summation of angle 1 plus angle 2, right? So how do we find this particular angle, right? Now we know this big triangle AEF, the two sides is 13 and 13, right? What about this side? Can we figure out what's going to be this side, right? What's going to be the length of this side? So ADF is a right angle triangle, right? So AD is 17, right? And then 7. So let's just so 17 square plus 7 square equals to what? 17 square. That's let me see. Let me try to find out what's going to be 17 times 17, right? 17 times 17. 982. So it's 289, right? So it's 289 plus 49, right? It's gonna be 338, right? 338. What does 338 looks like? Let me try to factorize. 338, 2, 1, 6, 9, right? Okay, I see. It's gonna be so this is gonna equal to what? 13 times square root of 2, right? So this length is 13 times square root of 2, right? So this is 13, this is 13, and this is 13 times square root of 2. So what does it show you, right? It shows you that this is actually a right angle. It's a 90-degree angle, right? Because this thing, 13 square plus 13 square, that's 2 times 13 square, right? So this is actually a right angle, 90 degrees. So that means this is 45 degrees, right? So all you have to do is to use 180 degrees to subtract 45 degrees, right? So angle 1 plus angle 2 equals to what? Equals to 180 degrees subtract 45 degrees, right? That's gonna be 5, 3, 135 degrees, right? And that's our answer.